Okay, I'm gonna be starting soon, but now it's gonna play in 4 seconds. So I'm gonna let the ads go through and then we'll begin. Okay. Okay. I think the ad should be done. So, welcome everybody, welcome. I have some important progress updates about this little alarm clock thing. There seems to be a way to do this stuff, because last stream, I was having some issues doing multiple things, really. Asynchronous programming is not easy, and learning the syntax for Rust while doing it, also not easy. Another thing is trying to figure out a way to make it count, make our project count down. This is another thing that I figured out. Essentially, the short bit of it is that behind the scenes, I made a polling example. So it's just a one big old loop that's just sequentially going through each of our tasks at a very particular timed interval. It just works. So here it is. The contrast kind of makes it a little bit hard to see, but we have two buttons, or two timers here, and because this has been running for a while, this has already overflowed. You see, it's oh wait, hold on, wrong button. You see, this originally was 500 to kind of represent 5 minutes, but not without any 500, or sorry, not with like 60 seconds being the conversion, but instead like 99 when you subtract 1 from 100, or quote unquote 1 minute, you get 99. So it's really a seconds counter. Both of these are seconds counters right now. And yeah, you can see that it's going down and it's completely negative. But if we reset the entire program, that's where things get interesting. And there we go. This is where we actually have 2 timers. So right now, we'll just call this side white, because this white wire is coordinating to this button. White's turn is currently going on. They got to make a move in chess, and then they press their button, and boom, now it's black's turn, which is where this wire is going. Black needs to make a move, so they go over here. Oh, their turn's over. Now it's white's turn. Knight to e4, that kind of thing. So we at least made a working prototype. Not really what I like. It's not fully working because this is still just seconds. I want this to be 459 all the way to 0, or 459 to 400, and then back to 359, so on and so forth. You know, pretty neato. What else? I also, thanks, dude. Hold on, let me change how my OBS is showing stuff. Is that quick transitioning now? It looks like it. Looks like it. For some reason, this song has no sound. Oh wait, I just can't hear anything. Is any sound playing? I don't hear any sound. It's coming through on your end? Okay. Huh. Because I see it moving on the mixer, but I straight up can't hear it. Maybe I need to check my Windows sound settings real quick. I was hearing it for a little bit. Take a big sniff into the mic and see if we can hear it too. I'm sure you would. Where is my sound? Yeah. I came across I don't know if it's new, but speaking Northern Lion, came across a video today of him naming 100 women. And he's a natural at just connecting different ideas together. Yeah, I was watching him string together just so many names, and it was all like categorical. So you could see where his thought process was like, okay, I'm gonna talk about actresses now, and then I'm gonna go from here into Canadian astronauts or something like that. And then he sees like one name that kind of overlaps two different categories. He's the Zoomer Boomer. Yeah, that's very true, because he's definitely not a Zoomer, but you know, he can really get the Zoomers excited. He's entertaining. Why can't I hear it? I'm so confuzzled right now. I go to a YouTube video. Let me see if I can hear anything off of that.
When Reading 2 comes out, you think it'll be...
I legit can't hear. This is so bizarre. I am going to do a Hail Mary. And... oh wait, I have one more idea before I do that. Okay, I'm going to do a Hail Mary and unplug my audio interface. What about now? There we go. Yeah, really bizarre. Windows was defaulting to something else. Okay, anyways, right here, right over here, this is the Rust programming book. This is your Bible, or your, what do you call this? Scholastic catalog. So it's got all the good stuff. I come in here every now and then to try to figure out what is going wrong with my code. Can you link it in chat? Oh yeah, sure. There it is. There is the official Rust programming language Bible. This is kept and maintained by the Rust community. They have this one, and then they have a different one that has the context of embedded Rust, which actually, I mean, I'll link this one too. I've read this one all the way through, which gave me some better context, but I got both of these off of just the Rust languages website. I think it's on the front page maybe, or under their documentation. Learn, I think. Yeah, they have a couple different books. Lots of different books. Okay. Good luck. I haven't read WebAssembly or command line book, but diabetes, sorry. Yeah, no, that's understandable. Go ahead and shoot yourself up. With insulin, of course, with insulin. Anyways, or maybe you're eating. I made an assumption that you needed that. Maybe you just need sugar. Who knows? Okay. But yeah, this website, really good. Check it out. What is governance? Just talking about how Rust is maintained. Okay. Yucky. Let me go to what I'm looking for, which I think has to do with either ownership, referencing, or could be asynchronous. We're essentially looking for this one section that talks about this paradigm of like not creating shared memory between threads, but instead doing channels. That's what they call it. Just gotta find, oh, fearless concurrency. It's probably in here. Okay, let's see. I have a few different topics. We got message passing concurrency, shared state concurrency, sync and send traits, which extend Rust's concurrency to user-defined types, and how to create threads. So we're not going to be creating threads, but we will be taking some of the ideas, I think, from threads and using it in our situation. Is this the page with the quote? No, it's the next one, I think. Yeah, here we go. No, maybe it was on that first page, because no, I'm not seeing it. So this one's saying, here's the idea in a slogan from the Go language documentation. Do not communicate by sharing memory. Instead, share memory by communicating. So I think this is saying don't just make a global variable. Make it so your threads access this global variable by telling one thread, hey, check this out, One thread is talking to the other rather than they both are just trying to access memory. So let's see. They provide an implementation of channels, but you see a keyword here? Rust standard library. Ooh, that's our kryptonite. We don't mess around with that because we don't get to use a standard library in the embedded world. We explicitly say no STD. No. So, fortunately, this idea that I just had of looking at this has gone down the drain because you can't use it. There's a chance that somebody's tried to make one that doesn't use the standard library, but I don't know about that. And this one also using the standard library. Yucky. Don't like to see that. That's okay, because we have a backup plan. And this backup plan was this article that I found off of this website called Interrupt. And they just have a bunch of open source blog posts that people write on here. You get approved to write, I believe, but they usually write about very niche topics. And this one was a big one that I've been trying to figure out, which is asynchronous Rust on microcontrollers. They say Cortex-M. I would imagine the idea is that they extend to other chips too that compile Rust, but it's okay because we don't really care right now. We just want Cortex-M. So I'm not going to read through all this because I've already read it, but the gist of it is that asynchronous functions, you got two different functions doing two different things. You also have synchronous functions that look like this. They're saying that the async keyword is actually just what they call code sugar, I think. Just like shorthand for this phrase. This gets wrapped up by the async keyword, so you don't have to worry about it replying or returning a future, having to remember that to write it. You just write async and it knows, hey, you're using the future framework in the core of the Rust language. This is just explaining Rust futures. We're not really going to go over that. The idea is like it's similar to a thread, but this is a thread that is non-preemptive, meaning you can't stop it in the middle of it. You have to reach an await point, which this will maybe go over. Your async function needs to have await points in it, which basically means, hey, is data ready at this exact time? If it's not, leave this function, this async function rather, and go try another async function. So this is your like scheduler deciding to give up on that first async function and start working on another one. You kind of break down your tasks. They're just talking about this is a preemptive schedule, this is a cooperative schedule. The async uses a cooperative schedule, so it does do that context switching quite a bit. Or no, sorry. I misspoke. Preemptive does context switching where it's stopping in the middle of something. This one is stopping only after purple's done. It'll start blue. Okay. So here they talk about a example that they made for a Blinky. They have a main, which we've had in our past. They have a main, which is your entry point to asynchronous stuff in Embassy, because the executor is that master scheduler, or is that thing that's choosing the asynchronous functions that's going to run at any given time. And those functions are going to be all these tasks. And they only work if you have a .await keyword in it. The executor does not know to pick up or leave a function. Well, actually, you know what? I take that back. It knows how to leave a function, but if you have a loop, you definitely need an await to stop executing that loop. Otherwise, it's just going to be stuck here forever and ever and ever. And that was the problem I was seeing maybe last stream or a couple streams ago. But essentially, this example is this blink. It executes every 200 milliseconds. You see that every, and then this whole thing just comes out to be 200. And this basically means that, hey, every 200 milliseconds, you want this await to fire. So they created that. This is them going over the same code. Then they create another example, and this is the key that I was missing last time. I was looking all over for basically this right here. This up here is a solution to the problems I was seeing last time. It's a global variable that is atomically defined, meaning that it will only be quote unquote one instruction long in the assembly, and it cannot be preemptively stopped because it's defined as Boolean, or sorry, atomic Boolean. And this is in the core library. I've confirmed that. Now in their case, they're using it to detect the state of the button. Like Let's see, hold on, here we go. They got the same exact blink function, so the LED is blinking every 200 milliseconds, right? But they also are checking to see if the button has been pressed or not. Because if the button has been pressed, which means it got a rising edge, so the person or the user pressed the button down, it toggles the state. Fetch exclusive word essentially just toggles the state of this, and it toggles the state, which then toggles the LED manually. So you can have it manually be toggled or on a timer toggle. They're both affecting the same exact variable, but or not variable, but the same peripheral, but they are working asynchronously. You know, it can be changed by the timer or the button. So that's kind of neat. Now, I never got into making my own interrupt, but this explains how they even created this function in the first place. Because this function uses interrupts in order to work. The library known as Embassy created this function for external interrupt pins and probably some other devices. This is a asynchronous function that is powered entirely off of interrupts. And so they're just going to the source code here where basically like they created a external interrupt and not the polling. This is all in the library. I'm not going to go through this. You should read it yourself if you are really into it, but I'm looking for the key point here. I guess the key point they highlight here is that essentially you have an await situation. No, wait, this is IRQ. This is, okay, so IRQ is the actual returning of the interrupt. So the interrupt triggers when you press the button. That's always going to happen. But in their IRQ, they define some waking up of a future of the exact pin that you press or that you've configured previously. And this waking causes the asynchronous function that essentially has this await. It causes this to become passable now. It's no longer stuck or just waiting around. So that's the sauce. That's the magic sauce. Now, can I get around this framework and use my own interrupts? I'd like to think so, but I haven't tried. So first, we're going to try to do it without interrupts. We're going to time it. We're going to see how precise we can get it. We haven't upgraded our oscilloscope, or not oscilloscope, our oscillator. So it's going to be maybe a little bit noisy. But we'll just have to see how it goes. So, a little cameo of Last of Us 2, by the way. Never played it. Actually, this is Last of Us 1, I want to say. Yep, yes it is. Yes it is. But anyways, next. We want to open up the code. If I can find it. Here we go. Okay, so I have this really nasty implementation that's just a while loop. And, well, okay, so we're gonna hide all of this because none of this got used. None of this got used. This is the core of what you're seeing over to the right here. And in fact, I'm gonna reset it, put it back at its state. So one thing to note is because this isn't really tied to trigger off of a exact interrupt, but instead to trigger like clearing the flag and when the scheduler or executor comes back around to check if I press the button, me like pressing it really fast, if it was triggered off of some interrupt, this, oh well, now we're down here. This would work instantly, but unfortunately, because of this rule that is in this example, where you see you can't preempt the different tasks, even though I press the button back here, it doesn't get worked on until here. And if I'm no longer pressing it by this time, sorry, it doesn't want to work on it. So with this current like while loop implementation, you essentially have to hold it down to guarantee that when it cycles back around, it triggers it. Definitely a flaw right now, which is why this is not my final goal. Like, to get that feedback responsiveness, I feel like you need the interrupts, not this cycling kind of behavior. But let's see how it works with the cycling. Okay. Another thing I noticed, this is just a paradigm, is that it is hard to share variables between tasks, right? We mentioned that. So there's this paradigm where you create your own struct to represent your hardware at startup, and you initialize it all at once and then leave it there. So in my case, I just created this random struct PCB called PCB, and I only have like 3 things that I am physically attached to, which is the display and the 2 buttons. Yeah, I created them there. I declared their lifetime static, so that way they never get deallocated throughout the entire program. I've been learning more, and that's the exact terminology that is associated with this lifetime. Static means it lasts the entire life of the program. But if you had any other lifetime, it is simply what you define the lifetime of that to be. Okay, so yeah, like I made a struct, and then I tried like initializing the struct by having this init function, which that works, right? I initialized it down here and created this mutable struct, but I was also trying to make a struct to be my other global variable on like game logic, because this is a game. I mean, you can treat it as like a state machine. You're trying to figure out whose turn it is. You're also trying to figure out what the time of each player of the game could be. So I created, where's it at? I created this game state, right? Turn. It's white's time, a variable for white's time, a variable for black's time. Easy stuff. But that didn't really work out because I couldn't get this game state to be passed between my tasks of asynchronous function of the reading of a button and asynchronous function of displaying, which I no longer have. I kind of deleted, but I was running into some issues with that. So to make a quick and dirty solution, just to showcase, I created this game state with 2 values that didn't even get used. Which that could change. Like I could make this neater, but basically made total time, and I just said, hey, if it's white's turn and you press the button, make the terms black. Make it black's turn. If it's black's turn and black press the button, make it white's turn, you know? A simple logic to detect the button only if it's your turn. Next thing, if it's black's turn, make their counter go down. If it's white's turn, I just said else, make their counter go down every 1 second. So what it's just a wait, you simply don't move. It freezes the whole program. But if you had another task like this that actually gets initialized, this await would have you leave the context and come up here and try to execute this logic. So you can definitely play with it. It's just I don't know how, like if we get the feedback of pressing the button, if we're gonna get it to be as quick as we want it. So we'll just have to see. We'll just have to see. But if we're going off of this example, it seems that we really need to utilize the atomic stuff in order to have a shared variable. Because you can tell between these two tasks, LED blink active, this is the shared variable. Before, I was getting errors about the lifetime not being the same between these two, about the borrowing of these two not working out. Bunch of problems. But yeah, let's import these. So I think for the top here, we can do use core, and then we got to figure out which one of these it is. This is just the core functions built into Rust. Not the standard library, but the core functions. And I don't know if it's called like atomic. We're just gonna have to look a little bit. Could also Google it. I think it'd be faster if I did, so... Oh, hold on, let's borrow. Okay, it's just borrowing. Borrow mutex, that's interesting. Let's see. The patterns. Is that enumeration? I'm getting distracted. That's interesting though. Yeah, I'm getting distracted. Rust. Atomic operator. Operations, I guess. Not the sync. So we got some atomics mentioned here. Concurrency. I mean, that's when you'd use it. Ooh. Well, that's silly. This isn't the standard library. We can't be doing that. We need the core one. Yeah. Atomic. And here's our options for atomic. So they pretty much have every value. So it looks like it's just atomic access. Even have a pointer. Wow. But we just want a bool maybe? Let's see. What do we really want? To get started, we don't need, like with time, I don't think we need it to be accessed by multiple things. We definitely in this button need, this button needs to invert the game turn. So we're definitely going to need that as an atomic bool. In fact, let's go ahead and do that now. So my mistake before is I just used a normal bool, but in fact we needed an atomic bool. Okay. And to match the logic here, we'll make it true because that's what I initialized before. We're getting an error. What is this? Mismatch. Found it. Yeah, you had to do like, you need to allocate it as like, was it stack memory? Or not stack, heap memory. Essentially the portion of the code that's not going to get put on the stack. So that way it gets saved for the entirety of the program if it was C. So how do they do it? They just called a new. So atomic bool new. And this variable is going to be called, I'm just looking at it. Why do I need a variable? I could just type the value. Yeah, that's what I'm thinking. Turn state. It's never used. Okay, that's a warning. That is not a failure. So, in here, this is where we're going to call their function that they have here. They do this fetch XOR. So if I go ahead and type turn state, so this is in our logic for the button press. We have a few different options of functions. Let's maybe read through some of these to see if there's a better one, but I'm pretty sure fetch exclusive OR is going to be great. Returns immutable pointer to the Boolean. Doing non-atomic reads and writes on the resulting integer can be a data race. This method is mostly useful for FFI, not sure what FFI is in this case, where the function signature may use a pointer mutable pointer bool instead of a reference to atomic bool. Returning the pointer mutable pointer from a shared reference to this atomic is safe because the atomic types work with interior mutability. All modifications of the atomic change the value through shared reference and can do so safely as long as they use... Okay, well, they had to declare it unsafe, so that's already not a good start for me. I don't like unsafe. I did not mean to call format. Thanks for the follow. 6 long...
Hi, Mark.
Oh, hi, Mark. 6 long live chaos Twitch scam. What is that name? What is the story behind a name like that without it being an obvious scammer? That's a goofy name. That's a goofy name. I mean, that can only really mean one thing. That you're a scammer. Or a bot. Prove me wrong. Prove me wrong. Prove me wrong. Okay, but here we go. Fetch exclusive or. So what is this ordering thing? This is a new keyword that exists. Logical exclusive OR with a Boolean value performs exclusive OR operation on the current value and the argument value. Takes an ordering argument which describes the memory ordering of this operation. All ordering modes are possible. Note that using acquire makes the store part of this operation relaxed, and using release makes the load part relaxed. This method is only available on platforms that support... Okay, yeah, that's fine. Atomic operation. What do we got here? Atomic Boolean. New atomic Boolean. We got foo. We fetch foo. Alright, we fetch foo. 1 second. Just gotta turn off wallpaper engine because it's using a bunch of RAM. Okay. Exclusive OR. Ordering, and then they have something here. What is that? Sequence CST. I'm not sure what CST is. Let's have load. You're fetching something and loading it into something. Oh, you're loading in the value maybe? Not too sure. You get to choose the value. Yeah, if you load it, it's like the load operation if it's ARM, or sorry, assembly. So they have a sequence. Well, let's try and try that out. All right, so if this is true, ordering, use core atomic sync. What is this? Acquire relative, or no, it's acquire release. Has the effects of both acquire and release together. For loads, it uses acquire ordering. For stores, it uses release ordering. So this is assembly. This is straight up a function that's dealing with assembly, which makes sense. It's atomic. It's an atomic operation. Notice that in the case of compare and swap, it is possible that the operation ends up not performing any store, and hence it's just an acquire ordering. However, acquire release will never perform relaxed accesses. Corresponds to memory order ACQ release in C++20. I don't know C++20. I don't know what features that added, but okay. You can hash it. Wow. Well, these are all just random functions, actually. What is SUQ? Come on, show me SEQ CST. Like acquire release and ACQ reload. for load, store, and load with store operations respectively, with the additional guarantee that all threads see all sequential. So this is like your volatile, right? See all sequentially consistent operations in that order. Sequential consistent. Okay, no wonder it is used in this context. This operation is unsafe. Well, that's a bad start. It's because we called it mutable. What if we didn't? What if we didn't call it mutable? Okay. So